We have finished the demoing the training process, the learning algorithm for perception. We want to ramp it up to make things neater. What we will do is to create an object template for a perception. An object template is a class, of course. In Python, you define a class in this way. Let's call that my perception. Okay. In the class, you will need an initialization function. If you have used C++ or Java, this is a constructor of a class. That is, when you use this template to realize any object in the memory, this function will be firstly called. Every method, including the initializer or the constructor of the object, receives an instance reference, which is called self, and I think it is a self-explanatory, that refers to this object, and that is this pointer in C++. And some initialization parameters. We do not need this for now. Let's concentrate on our perception that can work on 4 attributes. Let's call that w dot array so in the previous implementation, for the convenience of illustrating the mathematical concept, I've used the homogeneous coordinate. That is, I give each sample a constant value 1. But in the practical implementation, I'd rather to separate the bias, because this will make the programming part easier. This is a constant. We do not need a real something like that. Okay. Excuse me. So the predictor, for the predictor, let me move this into a new cell. We need this cell. Let's clean that up, and let's add a new code cell here. So I'd like to copy this predictor directly into our perception object. Let's call this predict. It has a self. This is an object. It maintains its own w parameters, w and b. So we do not need w. We only need the x. Now x is an n×4 array. We do not need the user to handle the x. We will add the bias in the predictor. So the h value is this plus b. Because this is a method return. This is a method of this object. Remember that this refers to the object, and w is an attribute of the object, self.w and self.b. Okay. Yes. This is our prediction. Let's test it. See, perception, my perception. You need a pair of parentheses to indicate that you are not give this class to this variable. Rather than you want to, instead you want to use this as a template to create an object instance to give to this object. And let's use this percept predict. Use this to work on the action. We do not need the homogeneous action, we just need the action itself. Let's print out this value. Note that the self parameter, for the self parameter, you do not need to explicitly provide it when you call the method of an object, because Python will automatically inject the object instance of which you call the method into the first parameter, the self parameter, in the function invocation of this method. So basically, you are calling the predict method using the object of percept and the action. Okay, not surprisingly, excuse me. Next, we want to incorporate this procedure in a function where we want to fit the model parameter of this perception to data. Note, although the name of the data are the same here, x and x, this x accepts all kinds of data, training, test. This fit, you need the training data because you will need the corresponding y to fit the model. And in fitting the model, let's say x is also the array. We do not need comments here. Okay, let me recopy that. Let's make the indentation correct. Okay. Well, while true, prediction is self dot predict over x. Okay, and this logic is the same. We do not need the y train because we only have y. Let's remove the reporting function for now, and let's move this up. Okay, the update would be x this times y. So now the update takes place at self.w, and we also need to update the bias. The bias the direction of updating the bias should be the same as the corresponding annotation. Okay. We have discussed previously how about if we are dealing with some tricky situation where there is no straight line that can, there is no perception that can separate 100% accurately the training sample. We introduce some maximum value of iteration to limit the iteration of the algorithm. So we also break. So we need to give maximum iterations. This is let's call use an environmental constant value here. C. Okay. Sure. Later, you will have the freedom of providing this function some validation data so that it can check how the model performs with respect to the validation data along the way. But now, for simplicity, we just put things together like this. So let's define our model. And okay, let's fit it to our X train and Y train, and let's test it. Predict on X test. Let's check if it is the same as the Y test. Perfect. We'll create a perception. We fit the perception using our data, and the perception works perfectly on the test data. Note that this set of interfaces is universal. It reflects the procedure, the framework of generic machine learning. Recall, in machine learning, we have these elements and an algorithm. Well, this structure incorporates the algorithm and a hypothesis set. This defines what is in the hypothesis space, and the fit represents an algorithm that collects the data and according to some loss criteria and select one particular hypothesis in the hypothesis space and save that in the self storage of the model parameters that represent the selected hypothesis. And then you will use this to predict other observations for unknown target values. We can have a look at how the standard implementation in the scikit-learn library from sklearn.linear model import perception. We should have a perception here. Right. see this seek perception. Okay. Say let this to fit x chain y chain. Now we have a perception. Well, it has more resource and bells to play with, but basically it implements a similar function of this framework. And let us use this to predict x test should be capital X and compare it to y test. We got similar performance here. Okay, if you are interested in all the different options and extensions of perception, you can do that in a wiki way. Let me switch off this screen. Perception. You add a question mark. Okay, you get the help document of the perception, including all the meanings of the parameters. Hopefully we have examples as well. Yes. Okay.